Composition of functions. This lesson is about the composition of functions. A few years ago I was administering a pre-calculus test, a semester final, for another teacher when I ran across this thing, with this symbol between the F and the G. I really didn't know what to make of it. Was this F circle G thing multiplication of F and G? Is this a dot for multiplying that the printer forgot to fill in with ink? Or is this FOG as in fog? It got me thinking about San Francisco and London, both noted for their often foggy weather. Well, it's neither multiplication nor fog. This is the symbol for composition. This is the composition of f of x and g of x, and since then I've seen this concept addressed in every Algebra 2 or pre-calculus textbook I've consulted. How I missed this in my algebra career until then, I don't know, but I'm making up for it here in this lesson. As I often do, I try to find a real-world use for the concept of algebra, and I think I found one here. Then we'll proceed to the more abstract and give problems at the end. In this example, Jake is a sales rep at a high-end electronics store, Blue Moon Electronics. He sells home theater systems and other home consumer electronics. In order to promote an atmosphere of working together for sales and service, the 10 sales reps split the sales commissions evenly between themselves. Jake's allocable sales is determined by dividing the total monthly store's sales volume by 10. And then Jake's monthly sales commission is determined by taking his allocable sales and multiplying them by 5% or 0.05. And here's the composition part. This first calculated value according to the first function, Jake's allocable sales, the output of the first equation or function, becomes the input or independent variable of the second equation or function and is plugged into that next function as input. So the output of the first function becomes the input of the second function. Let's take an input of monthly store sales. Last month, Blue Moon Electronics had $300,000 in store sales, which is our input value for the first function. And to get Jake's allocable sales, we divide 300,000 by 10 and get 30,000 for $30,000. This number, 30,000, becomes the input value for the second function. And to get the output for the second function, we multiply the 30,000 by 5% or 0.05 and get 1,500 as in $1,500. Now we're going to proceed to the abstract. For the first function, to determine Jake's allocable sales, it will be g of x equals x divided by 10. And for the second function, to determine Jake's monthly commission, we have f of x equals 0.05x, which is 0.05 times x. To get f of g of x, we take the x divided by 10 and place it here in place of the x in the second function. So as a result, we have the composite function f of g of x is equal to 0.05 times x over 10. And simplified, the function becomes f of g of x equals 0.005x. So now with f of g of x, we can run the 300,000 through this composite function instead of running it through two separate functions. We get the same result for a single input of 300,000, 1,500. Let's look at this problem. If f of x equals x squared and g of x equals x minus 2, find f of g of x. In order to solve this composition of functions, we need to insert g of x, which is x minus 2, as a substitute for x in f of x. So accordingly, f of g of x equals quantity x minus 2 squared. That x minus 2 replaced the x. We got this because this binomial x minus 2 takes the place of x in the f of x function. And we can work out quantity x minus 2 squared using the box method. We have one of the binomial factors, x minus 2, on the top of the box, and the other binomial factor, also x minus 2, on the side of the box. And all multiplied out in the cells, we have x squared in the upper left cell, minus 2x in the upper right cell, minus 2x in the lower left cell, and positive 4 in the lower right cell. We combine the like terms, minus 2x and minus 2x, so that gives us f of g of x equals x squared minus 4x plus 4. Leaving the answer at the bottom of the screen, we're going to change the problem we just did. It's the same f of x squared and the same g of x minus 2, but now the composition instead is the function g of f of x. For this problem, we have to take this expression x squared from the f of x function and use it to replace the x in the g of x function. So that becomes g of f of x equals x squared minus 2. And since for this one we don't have to do anything else, we can box our solution for g of f of x in as correct. This shows that for these two functions, f of x and g of x, the order of function composition does matter. Let's do this multiple choice composition problem. If f of x equals x plus 3 and g of x equals x squared plus 2x plus 4, find the following composition of functions, and we're asked to find f of g of x. Then we have our multiple choice answers A, B, C, and D. Stop the video, solve the problem, then restart the video to see if you got the correct answer. The correct answer is D. Here is f of x with g of x inserted in place of the x in f of x, and combining like terms we get f of g of x equals x squared plus 2x plus 7. Here's the next problem. If f of x equals the square root of x and g of x equals e to the power of x, find the composition function g of f of x. Stop the video, solve the problem, then restart the video to see if you got it right. The correct answer is C. G of f of x equals e to the power of the square root of x. The arrow at the top shows how the square root of x replaces the exponent x in the function g of x. Now the next problem, find f of g of x if f of x equals the square root of x minus 5 and g of x equals x squared minus 12x plus 36. Stop the video, solve the problem, then restart the video to check your result. The correct answer is A. F of g of x equals x minus 11. If we insert the quadratic trinomial x squared minus 12x plus 36 in place of x under the square root sign, what we have is a square root of x squared minus 12x plus 36, then subtract 5 from that. And we can factor this quadratic trinomial x squared minus 12x plus 36. It becomes the square root of quantity x minus 6 times quantity x minus 6 and 5 subtracted from that. And that can be rewritten as the square root of quantity x minus 6 squared with 5 subtracted from that. And since the square root and the squared cancel each other, we have x minus 6 minus 5, which simplifies to x minus 11, which is answer A. A lot of these problems come back to the skill of factoring at some level. This has been the composition of functions. Thanks for viewing.